Hi, in this video we will learn how to apply another inference rule called Constructive Dilemma. Hi, this is Logic Self-Taught with Dr. Phi. In this video we'll learn how to apply and not to apply the Constructive Dilemma. The Constructive Dilemma is quite a complicated rule. It's perhaps the most complex of the rules that we've seen so far. Let's start by looking at some examples of real-life inferences that exemplify the rule. Abe will have Christmas pudding or 10 mince pies. If he has Christmas pudding, he'll get sick. If he has 10 mince pies, he'll get fat. So, Abe will get sick or fat. Ben will get a B or a C on the exam. If he gets a B, he'll get a computer. If he gets a C, he'll walk the dogs in the morning for 2 months. So, Ben will either get a computer or will walk the dogs in the mornings for 2 months. Let's look at the rule in symbols. We have a disjunction, P or Q. We have a conjunction of two conditionals. The antecedent of the first conditional is matched by the first disjunct. The antecedent of the second conditional is matched by the second disjunct. In this case, we are allowed to infer the disjunction of the consequence. To apply the rule, we have to have a disjunction standing on its own line and a conjunction, again, on its own line of two conditionals whose antecedents are the disjuncts of the mentioned disjunction. Given these two propositions, we can infer a disjunction of the consequence of those two conditionals. To apply constructive dilemma, we need a disjunction on its own line. We have one here in line 1. We need a conjunction of two conditionals. Again, that condition is satisfied on line 2. Third, the antecedent of the first conditional must match the first disjunct. Again, satisfied. The antecedent of the second conditional must match the second disjunct. Since these conditions are satisfied, we can infer a disjunction of the consequence. Consider a more complex case. It might take you a while to recognize the opportunity to apply constructive dilemma, but the conditions are all satisfied. We have a disjunction on its own line in line 1. We have a conjunction of two conditionals on line 2. The antecedent of the first conditional is matched by the first disjunct. The antecedent of the second conditional is matched by the second disjunct. Given that these conditions are satisfied, we can infer a disjunction of the two consequents. The constructive dilemma is quite complicated, so we have to be careful how we apply it, and we have to watch for certain errors, but some of the errors you already are familiar with. Let's look at the error that we mention every time, namely inference rules don't apply to proposition components. If you look at this example, you'll actually see that one was tempted here to apply the rule to the disjunction that is in the antecedent of the conditional in line 1. But of course, since we know that inference rules don't apply to proposition components, we know that this is a misapplication of constructive dilemma. And in this case, the proposition in line 1, in fact, is not a disjunction at all. Okay, here we have a misapplication of constructive dilemma. We have a disjunction on its own line. We have conditionals whose antecedents are the disjuncts, but note that we don't have a conjunction of the two conditionals, and that makes the application of constructive dilemma inappropriate here. Mind you, there are some natural deduction systems. For instance, Virginia Sklenk, excellent textbook, has another rule called dilemma, which requires precisely a disjunction standing on its own and two conditionals with the disjuncts as antecedents standing on their own. I mean, in such a system, the argument we've just seen is a perfect exemplification of the dilemma rule, but it's not an exemplification of the constructive dilemma. Constructive dilemma in this case is misapplied. However, it's also quite easy to see that you just need to apply one more step. You need to conjoin the two conditionals together in order to apply constructive dilemma. Unfortunately, the order in which the disjuncts, the conjuncts occur does matter. So in this case, you have a misapplication of the rule because the first conditional must have the first disjunct as the antecedent. That's unfortunately not the case, and likewise, this fourth condition is not satisfied. I won't go through the motions here, but it should be clear to you that you could apply simplification to line 2, get the conditionals out to stand on their own lines, and then conjoin them in a different order, in which case you would be able to apply constructive dilemma. Mind you, this kind of problem does not occur for the dilemma rule I just mentioned, but if you work with constructive dilemma, unfortunately you have to watch out for this. This is Logic Self-Taught. It's exercise time. Do all the exercises until they feel like a breeze.